So our next lesson would be about a preparation for our schematic diagramming later. So what I'm going to do is introduce to you some electrical, electronic, and logic components that we might be using when we are or we will be designing something for our circuit. Now, let me introduce to you first um, by electrical, electronic, and logic components. And I will just include some of the mostly used and symbols that we might gonna encounter. So while the basic and prior requirements for designing computer systems are block diagrams and flowcharts that tells us about the flow and the process that the computer system will take or will be going through. So majority of our lessons will be about designing the printed circuit and printed circuit board itself. And in order for us to make it, mas kailangan na natin pumunta dun sa detalye na sino na yung magkakakonect, ano na yung mga kailangan nating components, ano yung mga kailangan nating connections para build natin yung ating design sa PCB. So, mas dun tayo magpo-focus. So in this case, let me first introduce you to the description of the components that we might be using. So you'll find most of the schematic component symbols commonly used in electricity, electronics, and because we're dealing with computer system, we will be using logic components. So symbols indicate conductors, resistors, capacitors, and so on will be discussed. Again, I will stress out that I will just include some of the most common types of components that we are actually using for our printed circuit boards. Now, let's go get into the first group of components we will be discussing. That is about the electrical components. So the first thing or the first symbol that I will introduce to you is the wirings. Now, a wiring is a line between two symbols or part of symbols that represent, sorry for the typos, that represents an electrical connection. So it is represented in a simple line. So walang particular type of wire or conductor is implied kung anong klaseng wire man siya, kung siya ay copper or may isang meron kang naka-fiber ka. Basta it represents when we create a line, it means that we are trying to impose that there is a connection between two components that is at the end of each line. So, basic lang naman. So, these are some of the connections that we might be seeing pag naka-encounter na tayo na nagde-design. Pwede siyang straight line, pwede tayong gumawa ng connections of the wires that crosses each other. So, it doesn't necessarily mean na kailangan nating magbuhol ng wire and then connected. Ibig sabihin lang, merong isang line na papunta dito and then they cross each other whether they or not sharing the same point. So, pag pinilitan natin sila sa PCB, if we create something like this one, it's a, let me just, yes, get a pen. Just stress out the difference between these examples of connections. So, these are some of the connections of wires that crosses each other. So, kung makikita ninyo, zoom in ko para makita ninyo that there's a difference between these two. This one, ito, parang nakita natin may dot dito, or should I emphasize it, this one? Yan, may dot siya. Anong ibig sabihin nito? This one, this necessarily mean that they are connected, but they can cross each other in a way na hindi ibig sabihin magkakonekta sila. Maaaring ito yung wire na kapag ganito, crosses each other, but they are not connected or they are detached. Now, if you see na merong ganito yung ating wires, ibig sabihin, it actually indicates that the two wires that crossing each other is actually connected or soldered to each other. Ibig sabihin, ito, konektado talaga siya dito. Hindi lang siya basta lumusot kasi nag-cross lang sila ng path along the design. So that's the big difference. So when you see that a designer indicates a dot on the wirings, ibig sabihin, it is soldered, magkakonekta yung dalawang wires. Ibig sabihin, if there's a component right here, it is connected to both end of the component. If there's a component right here, wala siyang kakonekta dito. So, ang magkakonekta ito at saka ito. If there's a component right here, they are connected to three of the components and vice versa. Now, moreover, there is also a symbol that represents that the wire is connected to the ground. So this is the symbol that represents that it is connected to the ground. Now let's go to the next component. We have the inductors. So this one is the real, ito yung totoong itsura or totoong picture of the inductors. And this one is how we would like to see it in our schematic diagram. So when we see this one, it means that the component attached into something is an inductor, sorry. So what is an inductor? An inductor is a passive electrical component consisting of a coil wire, this one. So it comes in different form, but it's just a coil of wire which is designed to take advantage of the relationship between magnetism and electricity as a result of an electric current passing through the coil. So when we say inductor, so it takes advantage of the magnetism and the electricity as a result of electric current passing through the coil. So it is also a conductor in the sense that it allows passing of electricity, but the purpose is not for conducting. So ginagamit siya usually kapag yung sa AC circuit, sa alternating current circuit. So parang siya if the conductor is responsible for the voltage, inductor is responsible for the current. Yeah. So a basic inductor comprises a length of wire that is coiled up in order to introduce inductance into a circuit. So the property opposes change in existing current. It acts in practice only while current increases or decreases. So gaya nga nasabi ko, ang minamanage niya, if the conductor manages the voltage inside the circuit, ang tinitake in management naman niya ay current. So coils in the inductor can range in physical size from microscopic to gigantic. So the basic unit of inductance is the Henry. It slows down the current surges. So siya yung kaya nasabi ko kanina, siya yung nagmamanage, hindi ko mas-specific in term, but basta siya yung nagmamanage dun sa current na pumapasok dun sa ating circuit. So it temporarily stores energy in electromagnetic field and releases it back into the circuit. So when do we use inductors? So we use it for choking, blocking, attenuating, and filtering smooth high-frequency noise in electrical circuits, more likely responsible for the current, for the alternating current. Yan ang kanyang responsibility. So storing and transferring energy in power converters, DC-DC or AC to DC. So creating tuned oscillators or LC tank circuits. So converter siya from DC to DC. Kung DC yung papasok sa kanya, DC pa rin yung output niya. Pero kung AC, so convert ito to DC. Or ima-manage niya or responsible siya to making it into DC. Now, impedance matching. When the current flow, that should be, yeah. When the current flowing through an inductor changes, kapag siya nagbago yung current, kasi the time-varying magnetic field induces an electromotive force. So Faraday described this as law of induction. So according to Lenz's law, the induced voltage has a polarity which opposes the change in the current that is created. So as a result, inductors oppose any change in current through them. Kaya mas maganda siyang ginagamit to regulate or to change from AC to DC. Now, this is the symbol for the inductor. This one is a symbol for a variable inductor. Ibig sabihin, it changes. So, every time, kahit sa ibang component, pag nakakita kayo ng arrow that's pointing this way or upward, it means the value or something. It is a variable component. Nagbabago. Now, let's go to transformer. So, transformer this is the actual component for transformer, but this is how it is represented in a schematic diagram. Para siyang dalawang inductor na magkabaliktaran. So what is a transformer? So kanina sabi natin, the inductor itself is responsible for regulating the current. Kaya nga, pag ginagamit siya lalo na pag AC circuit mo. So, ibig sabihin, in a way, a transformer converts a changing or a surging current into a more tamed current. Parang ganun. So, a transformer is an electrical, on the other hand, kung ikita natin, a transformer is an electrical device designed to transfer electrical energy from one circuit to another at the same frequency. So, kumbaga, isipin natin na siya ay mas advanced function kaysa sa inductor. So it's also referred to as a static machine since it doesn't have any moving parts. It is used to control the voltage levels between the circuits. So siya naman is responsible for controlling the voltage levels in order for it to be regulated or for it to be normal, usual, kalmado, kung ano man yung term na pwede natin magamit. So transformers are capable of either increasing or decreasing the voltage depending on how it is parameterized to do or ano yung parameters. So decreasing the voltage and current levels of their supply without modifying its frequency. So ginagawa niya is, kumbaga sa atin is, I'm gonna change you into something that's more behaved but of the same performance, or the amount of electrical power being transferred from one winding to another via the magnetic circuit. So this one's a variable transformer. Next, switches. So switches is switch is a device, mechanical man siya or electrical, that completes or breaks the path of the current. So it is the main component that can control or allows the flow or do not allows the flow of the current or the voltages. So it is any device used to interrupt the flow of electrons in a circuit. It can say go, it can say stop. Switches are essentially binary devices kasi 1 and 0 yung kanyang alam. It's either you go or not. So the simplest type of switch is one where two electrical conductors are brought in contact with each other by the motion of actuating mechanism. So yung simple type of switches ay yung, di ba, pag connect ng wire, that's on the it can flow. Pag hindi sila magka-contact, then it will be off kasi walang mag-flow. So in any case, the final output of any switch will be at least to turn off or to close and open the circuit, the flow. So there are some types of switches I've introduced here. We have the toggle switches. Kung nakakita na kayo niyan, paano yung nag-work on, off, ganun lang kasimple. So this is the symbol for the toggle switch. So toggle switches are actuated by a lever that goes up and down depending kung up siya is on and down is off. So most toggle switches will come to rest in any of their lever positions, while others have an internal spring mechanism returning the lever to a certain normal position, allowing for what is called momentary. Now, toggle switch is manually actuated. Kumbaga manual natin siniswitch. So, kailangan natin pumunta and turn it on if you want it to work. So, joystick switches. Ano naman yung joystick switches? A joystick switch, this is the symbol for the joystick switch, is actuated by a lever free to move in more than one of the axes. Mas nakakapag-move siya. You know, you've seen a joystick one, yung kahit yung normal. Paano siya nag-work? Paano natin nilalaman kung alin yung masaswitch sa kanya? You can actually turn this one right, up and down. So it has one or more of several switch contact mechanism and are actuated depending on which way the lever is pushed. Sometimes by how far it is pushed, dun siya nag-trigger ng kanyang on and off status. So the circle and dot notion on the switch symbol represents the direction of the joystick lever motion required to actuate the contact. So joystick hand switches are commonly used for crane and robot control. So next we have here the limit switches. So this is the symbol for the limit switches. This is when it's normally open, when it is closed. Yeah. Now this is how it looks like in the actual. So these limit switches closely resemble rugged toggle or selector hand switches fitted with by a lever pushed by the machine part. So these switches consist of a bumper type of arm actuated by an object. For it, this one, it was designed so it's easier for it kahit machine lang yung mag-trigger ng on and off ng switch. So when this bumper arm is actuated, it causes the switch contact to change position. Now we have the proximity switches also that is represented this way. So proximity switches sense the approach of a metallic machine part are driven by a magnetic or high frequency electromagnetic field. So simple proximity switches uses a permanent magnet to actuate a sealed switch mechanism whenever the machine part gets close. So it is kumbaga, triggered by electromagnetic field. So siya yung hindi manual. Actually, manual pa rin siya in the type na machine yung nagpo-push sa kanya. Pero siya ay triggered by, if malapit na yung machine, it will be triggered by the magnets and it will causes change in the switch. So, sorry, this one should be electronic. So let's go into the electronic group of components. So first we have the resistors. So this is the symbol for the resistors. There are different symbols that you can see. This one's for the US and Japan type of schematic diagrams, and this one is represented in Europe. Pero ito yung gagamitin natin, the US and Japan type of symbols for the resistors. So this is the actual resistors, and this is how we'd like to assign it into our diagram. So resistors are electronic components, also well known as passive electrical components, and is responsible to resist the flow of electrical current. So this means that it limits the flow of electric current in a circuit para to drop the voltage, to limit the current, attenuate signals. It can also act as heater, act as fuses, and divide voltages. So it's the simple go-to component, electrical component, if we don't need much of an effort to do such things. Kung wala tayong fuse, then we can actually use this as it can act as fuses. So the value or size of a resistor is measured in units called ohms. So typical types of resistors, we have here fixed resistors. Pag sinabi natin fixed resistors, the value of its resistance cannot change. It will be the same all throughout the circuit. Kumbaga parehas lang yung resistance na ina-impose niya. Hindi yan magbabago. Pero pag nakita tayo ng ganito, natin changes its resistance. Siya naman is it changes or adjusts its resistance dun sa circuit. So pwede natin siyang ma-adjust. So they are also called potentiometers or rheostats and allow the resistance of the device to be altered by hand. So we also have the nonlinear resistors, which has the resistances that vary significantly with applied voltages. So temperature light. Types of nonlinear resistors are varisistors, thermistors, and photoresistors. We also have here a capacitor. So ito yung symbol for our capacitor, and these are the components for it, the real-life components. So capacitors are electric components that have the ability to block direct current. So siya naman ay kaya niyang mag-block ng DC at it allows AC to pass. So they also store electrical energy. The basic unit of capacitance is farad. So, unless the symbol includes a polarity design, ang usual na design nitong symbol means it is unpolarized or non-polarized capacitor. So, which might be made from metal plates surrounding ceramic, nickel, glass, paper, or other solid non-conducting material. So, the material designation indicates the insulation, technically known as dielectric, that separates the two major parts of the component. So all capacitors that we have seen so far have a fixed design. In other words, the components specified no provision for changing capacitance value. So however, we do have the ability to change the value of the capacitors. So these components are generally called variable capacitors. So again, the variable capacitor is designated by the usual symbol for the capacitor and then an additional arrow. So a diode, on the other hand, is this one, and it is represented using this one. Yung part na nakaturo, yung triangle is the negative side or the cathode, and then the positive side and the anode yung end niya. So a diode is a semiconductor device that essentially acts as a one-way switch for current. So it allows current to flow easily in one direction. So siya yung nagko-control ng direction flow of the current. So, but it severely restricts current from flowing on the opposite direction. So hindi babalik yung current mo. So siya yung nagko-control na puro pasok lang yung current na nagko-flow sa yung circuit. So, diodes are also known as rectifiers because they change alternating current into DC. So, marami tayong mga components na pwedeng gamitin if we want to regulate or change AC to DC. Diodes are rated according to their type, voltage, and current capacity. So, these are some types of diodes. Now, diodes have polarity. So, positive yung lead, tapos yung cathode, yung sa may end yung tinulo natin kanina, the negative lead. Now, most diodes allow current to flow only when positive voltage is applied and then going into the, kasi diba, let's see. The current will only flow if the polarity is positive. Now, kapag siya nag-pass through this, hindi na siya makakabalik kasi negative na yung ating polarity here. So, that is the concept of the diode. So, when a diode allows current flow, it is forward bias. So, forward bias ito. However, kapag baliktad yung polarity, it is reverse bias. What is reverse bias? It acts as an insulator and does not permit current to flow. Ibig sabihin, pagdating dito, since nandito yung negative polarity or negative lead, hindi makakapasok ang electricity. So, yung mga nandito lang type of current, so not electricity, the current. So, nandito na type of the current, mag-stay lang siya dito. So, parang it blocks the current, the flow of the current. So, dito walang nakakapasok. Dito, nag-stay lang dito yung kung meron ditong current. Now, some of the symbols for variable diode are here. This one. So let's go to the transistors. Transistors are this one. We usually see this one kapag nag-open tayo ng PCB natin. So this is the symbol for the transistors. So transistors are made from silicon, a chemical element commonly found in sand. So they were first invented over a half century ago, and it was used to replace the vacuum tube. Then from transistors, we got into the IC, yun yung transition of the computing devices, the computers. So it can do two different jobs. Bakit ginamit kaya yung transistors to replace vacuum tubes? Kumbaga as the brain of the computer, right? So it can work either as an amplifier or a switch. So when it works as an amplifier, it takes a tiny electric current at one end and produces a much bigger electric current. So it amplifies or increases. Parang ganun. Actually, amplifiers do such thing. It increases. Mas pinagmamagnify niya yung value of what's entering into it. So, siya, sa transistor, yung current is, it converts it or it transforms it into bigger electric current at the other end. So, it's also called a current booster. Now, transistors can also function as switches. So a tiny electric current flowing through one part of the resistor can make a much bigger current flow through another part. In other words, small current switches on the larger one. This is essentially how all computer chips work. Kaya siya yung ginamit natin to replace the vacuum tubes. So, the four transistors operation modes are saturation. The transistors act like a short circuit where current freely flows from one collector to emitter. And then we have the cut-off operation wherein the transistors act like an open circuit. Walang papasok. Kapag naka-open yung circuit, walang papasok na current flow. So active. Active mode of the transistor is the current from collector to emitter is proportional to the current flowing into the base. Pag sinabi naman natin reverse active, the current is proportional to the base current. Now, the transistors are fundamentally three-terminal devices. Ibig sabihin, there are three connections that we are expecting when we have the transistors. So one, on a bipolar junction transistor, those pins are labeled as collector, base, and emitter. So tatlo yung kanyang connection. So kung makita natin, tatlo yung paa ng ating transistor. One of it is the collector base and one is the emitter. So next one is the cells and batteries. So a cell or battery is often used as a power source for electronic circuits. So usually ito yung ilalagay natin pag mag-build na tayo ng ating circuits. So this is how it can be represented. It means this is a multiple battery. Marami itong battery. And then this one is a single battery. The polarity, positive and negative. And we have to take note of that. And I know aware naman kayo kung paano natin i-assign or alin yung positive or negative side of the battery. Now, electrochemical batteries are classified into four broad categories. We have the primary cell. Sorry, that should be a highlighted. So a primary cell or battery is one that cannot be easily recharged after use. Now, the primary cell is the one that cannot be recharged. So ito yung mga usually dry cells na pag nagamitan natin is out na. Now we have also our secondary cell or battery, which is one that can be recharged. So these are our chargeable batteries right here that we can use for our circuit. We also have cells, what we call cells, that are utilized as energy store devices. It delivers energy on demand. So typically, it's connected to primary power sources so as to be fully charged on demand. So examples of this type of secondary cells include emergency, no-fail, and standby power sources. So cells that are essentially utilized as primary cells but are recharged after use rather than being discarded. So examples of these types are portable consumer electronics and electric vehicles. Now let's move on into our logic components. So all digital components or all digital electronic devices employ switches that perform specific logical operations. So this is one that we are expected to have on our circuit since we are dealing with computing systems. So we use logic components and such components are actually just switches that performs in a binary fashion. So switches called logic gates, and for a certain amount of binary input, it reacts and produces another binary output. So logic devices have two states represented by 0 and 1. So 0 is low and 1 is high. You can also state it as high, up, as on and off. So if it's low, it is off. If it's high, it's on. So we have it here. Yeah. Nasa baba pala, hindi ko pala nilagay dito sa gilid. So we have the first logical component that we have which is the logical inverter. It inverts 0 into 1. So if there is an electric passing, kumbaga kung 1 ang charge nang pumasok sa kanya, the output will be 0 or off. If 0 pumasok sa kanya, it will be on, it will turn on. So it has one input and one output at that. So an OR gate, I know very familiar na kayo, an OR gate naman ay meron siyang two inputs that once, basta meron lang isa ang may mag-flow o may high na current na pumasok sa kanya, it will turn on, it will produce a high current. So magkakaroon ka ng on status. Pero pag parehas 0, off siya. So, the AND gate on the other hand, iba naman siya, basta magkaroon ka ng 0 input sa kanya, 0 na rin yung output niya. So, yun yung tatandaan natin. Sa OR gate, magkaroon regardless of ano yung kasama niya or kasabay niya, basta meron siyang isang 1, 1 na rin yung kanyang output. Nagiging 0 lang siya pag parehas 0 yung input mo. Now, the AND gate works differently in a way that kailangan niya is parehas lahat ng input mo ay 1 para siya maging 1. Else, it will all be 0. Now, an OR gate can be followed by a NOT gate. Ibig sabihin, it will invert what the OR gate will produce. So, ang tawag dito ay NOR gate or NOT OR. Kasi meron tayong dalawang component. It is actually composed of an OR gate and a NOT gate. So, ibig sabihin kapag meron kang input na 0, 1, the output of the OR gate is 1. But given that there is an inverter, magiging 0 na yung ipoproduce ng component. So, if it is 0, kung parehas 0 yung input mo sa yung OR gate, it will output 0, but given that there is an inverter, it will output 1. So, the AND gate can also be followed by a NOT gate, therefore, turning it into a NAND logic gate. So, a NAND logic gate, ganun din sa kung anong output niya, i-invert. So, if you have a 0, 1, the AND gate will output 0, but the NOT gate will convert it into 1. So we also have this, what we call an exclusive or XOR gate. So an XOR gate has 2 inputs and 1 output naman. So if 2 inputs has the same states, then the output equals 0. So kung both 1 siya, 0 ang output. If both 0, then 0 ang output. So siya ay nag-1 lang kapag magkaiba yung input mo, yung values ng input mo. So this is our example this is our symbol. This is our inverter. This is our OR gate. This is our AND gate. Ito yung NOR. Ito yung NAND. Designated by that dot right there. And this one is the XOR gate. Designated by this one right here. So these are the symbols that we might encounter in our logical components or while we are building the circuit. Now I've included some of the added or additional specific symbols that we might encounter when we are dealing with our schematic. So you're free to have this as a cheat code para malaman nyo kung ano kaya to, hindi ito na-mention din sa module. So these are some of the other components that our circuit can contain.